equation, we have to evaluate the definite integral 2x plus 3 divided by 5x square plus 1 into dx from 0 to 1. Let's begin with the solution. And we have to find the value of this integral. First, let us find the value of integral 2x plus 3 divided by 5x square plus 1 into dx. This can be written as 2 times integral of x upon 5x square plus 1 into dx plus 3 integral of dx upon 5x square plus 1. Let us denote the first integral by I1 and the second integral by I2. First, let us solve the integral I1. In the integral I1, let us suppose that the denominator 5x square plus 1 is equal to t. So this implies that 10x is equal to dt upon dx. This we get on differentiating both the sides with respect to x. This implies that x into dx is equal to dt upon 10. So this implies integral I1 can be written as dt upon 10, taking 1 upon 10 outside the integral. We have dt upon t, where t is equal to 5x square plus 1. So this can be written as 1 upon 10 log of mod t, that is 1 upon 10 log mod of 5x square plus 1. Now let us consider the integral I2. In the integral I2 we have integral dx upon 5x square plus 1, that is integral dx upon root over 5x whole square plus 1 square. Now let us assume that u is equal to root over 5x. On differentiating both the sides with respect to x, we have du is equal to root over 5 into dx, or dx is equal to du upon root over 5. Therefore, integral I2 can be written as du upon root over 5, taking 1 upon root over 5 outside the integral, we have du upon u square plus 1 square. So this is equal to 1 upon root over 5. 1 upon 1 tan inverse of u upon 1, that is 1 upon root over 5 tan inverse of root 5x. Now this integral is equal to 2 into I1 plus 3 into I2, that is integral of 2x plus 3 upon 5x square plus 1 into dx is equal to 2 into I1 plus 3 into I2. So we have 2. I1 is 1 upon 10 log mod of 5x square plus 1 plus 3 times of I2, and I2 is 1 upon root over 5 tan inverse of root 5x. This is equal to 1 upon 5 log mod of 5x square plus 1 plus 3 upon root over 5 tan inverse of root 5x. Let us denote the antiderivative of this function as capital Fx. Now, by the second fundamental theorem of integral calculus, integral of fx dx from a to b is equal to the value of the antiderivative at the upper limit minus the value of the antiderivative at the lower limit. Therefore, integral of 2x plus 3 divided by 5x square plus 1 into dx from 0 to 1 is equal to the antiderivative fx, which is 1 upon 5 log mod of 5x square plus 1 plus 3 upon root 5 tan inverse of root 5x from 0 to 1, and this is equal to 1 upon 5 log mod of 5x square is 5 plus 1 plus 3 upon root 5 tan inverse of root 5 minus 1 upon 5 log mod of 1 plus 3 upon root 5 tan inverse of 0. Now tan inverse of 0 is 0 and log 1 is also 0. So this is further equal to 1 upon 5 log 6 plus 3 upon root 5 tan inverse of root 5. Therefore, integral of 2x plus 3 divided by 5x square plus 1 into dx from 0 to 1 is equal to 1 upon 5 log 6 plus 3 upon root 5 tan inverse of root 5. This completes the solution.